Okay, listen up. Welcome to the flight deck. If you are currently navigating the incredibly high stakes, high pressure syllabus of Cambridge mathematics, and I'm talking whether you're tackling the 0580, the 0606, the 4024, 4037, or the 4040, you already know that the margin for error is razor thin. It is literally make or break. Today, we are decoding the exact step-by-step methodology you need to prove line and circle intersections. Think of this explainer as your advanced, top-tier strategy briefing. We aren't just here to find the right answers today. Honestly, anyone can guess an answer. We are going to lock onto the precise, rigorous, ironclad methodology that Cambridge principal examiners absolutely demand. Far too many candidates approach these specific exam papers relying entirely on gut instinct, or maybe just raw calculation alone, and they end up leaving a massive amount of method marks on the table. It's a tragedy. So today, we are completely upgrading your approach. We're going to look at exactly how to determine whether a straight line is a tangent, a chord, or just totally misses the circle and doesn't intersect at all. And we're going to do it with absolute, undeniable mathematical precision. Are you ready? Let's get right into it. Look at the quote on your screen. This is a direct red alert warning straight from a Cambridge senior examiner. Quote, "Most students lose easy marks on determining whether a straight line is a tangent, a chord, or does not intersect a circle." End quote. Now you really have to ask yourself, why on earth does this keep happening year after year? I'll tell you right now, it is absolutely not because the fundamental algebra is impossible. You all know how to do algebra. It's because of the core challenge of securing method marks through multi-stage analysis. You see, students get stressed. They do the rough working in their heads, they scribble down this completely chaotic substitution on the page, and then they literally just jump straight to a conclusion. Oh, it's a tangent. But here's the reality check. Cambridge doesn't just want to know if you can guess the final landing spot. They want to see your complete, undeniable analytical process. They award the big points for the explicit steps you take. When you face a question that uses the command word determine, you are actively being tested on your ability to set up a systematic, evidence-based causal relationship. If you miss a step, even a tiny one, you lose the marks, period, even if your final answer is miraculously correct. So we are going to fix that bad habit right now. All right, here is our flight plan for today's mission. First, we'll break down the challenge, analyzing exactly where typical students completely derail. Second, we're locking in target terminology, because words matter in math. Third, we'll run through the procedural framework, which is your new best friend. Fourth, we'll navigate the danger zones where marks vanish. And finally, we'll synthesize your ultimate success blueprint. Okay, let's look at a real Cambridge mathematics past paper scenario. Consider two typical student archetypes, and be honest with yourself. See if you recognize either of these. First up is Alex. Alex is our classic data dumper. Alex overloads the exam page with raw mathematical facts, writing out every equation possible, but with absolutely zero format or structure. There is no clear algebraic progression from the initial substitution to a simplified quadratic equation. It is just a massive wall of unstructured numbers. The examiner literally has to hunt for the logic. And let me tell you a secret. Examiners despise hunting. Then we have Sam. Sam's problem is entirely different, but just as fatal. Sam is a rusher. Sam rushes the math, totally missing the context and completely ignoring the specific command words. If the question explicitly says determine, Sam just scribbles, "It's a tangent" at the bottom of the page without clearly stating the mathematical proof that actually led to that conclusion. Sam misses the crucial command word requirements entirely. Both of these flawed logic patterns are actively stealing method marks right out from under you. Our goal with this explainer is a total transformation. We are moving you far away from Alex's chaos and Sam's impatience, and we are going to turn you into a structured, highly analytical, top-tier candidate. Before we dive into Section 1, target terminology and defining our coordinates. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's talk about words. You simply cannot execute complex algebraic proofs without precise definitions. It's impossible. Let's start with a tangent. By definition, a tangent is a straight line that touches a circle at exactly one single point. Visually, it just grazes the edge. This definition is the absolute baseline for your evidence-based causal relationships in these exams. In the strict language of algebra, what does this actually mean? Well, when you substitute the equation of your straight line into the complex equation of your circle, you are naturally going to form a quadratic equation. If that straight line is indeed a tangent, that resulting quadratic equation will have exactly one repeated real root. This means your discriminant, the one, that famous b² minus 4ac from the quadratic formula, that discriminant must be exactly equal to 0. That right there is the causal relationship the examiner is looking for. The word tangent is your point, the calculation of the discriminant is your concrete evidence, and equating it to zero is your mathematical explanation. You must anchor this specific academic vocabulary deeply into your mind. If you drift from this precise definition, your entire proof crumbles. Conversely, let's look at a chord. A chord is a straight-line segment whose endpoints lie directly on the circle. Picture slicing through the circle with a sword. This means the line intersects the circle at exactly 2 distinct points. Now, let's translate this academic terminology straight back into our algebraic framework. If you substitute the linear equation into the circle's equation and you form your quadratic, a chord means you will definitely have 2 distinct real roots. Therefore, your discriminant, again, b squared minus 4ac, must be strictly greater than 0. Now listen closely, because the principal examiner reports directly address this specific issue year after year. Candidates consistently confuse these key terms. They will do the math perfectly, calculate a discriminant of, say, positive 12, which is greater than 0, but then they will mistakenly write, therefore it is a tangent. No, that is a massive, glaring red flag to an examiner. It shows a fundamental disconnect between your mechanical calculation and the actual geometric concept. By clearly defining and understanding these terms, you essentially build a fortress around your method marks. Moving into Section 2, the procedural framework. It's time to move out of the textbook definitions and get into the simulator. We need structured reasoning because Cambridge prioritizes analytical depth over just getting the right number at the end. Okay, interactive challenge time. I am putting 30 seconds on the clock. Look at the 2 mathematical paragraphs presented on your screen right now. Which student is actually applying a structured method strategy instead of just guessing the final answer? Look closely at the working out. All right, time's up. Did you spot it? One of them jumps straight from a really messy substitution to just stating discriminant equals 0, so it's a tangent. That's Alex again, skipping steps. There is no clear, unbroken evidence trail. To avoid this trap, top-tier students use what we call the PEEL framework, P-E-E-L. Point, evidence, explanation, link. Your point is your initial algebraic setup. Your evidence is your meticulous step-by-step calculation. Your explanation explicitly states what your numerical result actually means, and your link is your final, definitive concluding sentence tying it right back to the question's command word. If you looked at the other answer on screen, that student meticulously showed the substitution, carefully expanded every bracket, set the entire quadratic to equal 0, calculated the discriminant with crystal clear notation, stated that the result is 0, and concluded with a full sentence referencing the exact terminology. That is Sam, but a newly reformed Sam who is now religiously using the PEEL framework. This exact level of structured reasoning is your golden ticket to guaranteeing full marks. So, how do we do it every single time? Here are the 5 critical phases required to completely dominate these intersection questions and secure every single method mark available. Phase 1, deconstruct the question. What is the actual command word? Are you proving it's a tangent? Are you finding the exact coordinates of a chord? Or are you just showing there's no intersection at all? Phase 2, extract the relevant data. Write down your linear equation and your circle equation perfectly clearly. Rearrange that linear equation to make either x or y the subject. Phase 3, select your analytical framework. For this topic, this is almost always going to be substitution, followed immediately by the discriminant test. Phase 4, execute with clear notation. This is exactly where the vast majority of students crash and burn. You need to substitute carefully, expand your binomial brackets without dropping any negative signs. Seriously, watch your minus signs. And this is crucial. Gather all your terms to one side so your quadratic equation equals exactly 0. You simply cannot find your true a, b, and c values until the equation equals 0. Finally, phase 5, present with correct terminology. Calculate your discriminant. If it's a negative number, don't just stop. Explicitly write b squared minus 4ac is less than 0, therefore there are no real roots, therefore the line does not intersect the circle. You have to complete that entire logical chain for the examiner. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. When you apply this 5-step procedural framework, I promise you, your answers literally physically transform on the page. All that red pen just disappears. The examiner doesn't have to squint and guess what you were trying to do in your head. By explicitly writing out your a, b, and c values before plugging them into the discriminant formula, you are openly proving your analytical depth to the grader. You are providing the exact evidence demanded by the PEEL framework. Remember, at this level, it isn't just about getting the math right, it is entirely about communicating your mathematical logic flawlessly. All right, Section 3, Navigating the Danger Zones. Let's enter our interactive workshop. It's time to train your eyes to spot exactly where these precious method marks are being lost by other candidates. Think about this scenario for a second. Imagine a student who calculates their discriminant flawlessly, and they get -15. Great math. But then they write, the answer is -15, so it's a chord. What just happened? They executed the calculation perfectly, but they totally failed the terminology check. A negative discriminant explicitly means no real roots, which geometrically means the line does not intersect the circle at all. Calling it a chord is a massive, fatal error in analytical reasoning that ruins the whole question. This perfectly sets up the top 3 warnings pulled straight from the confidential principal examiner reports. Warning number 1, forgetting proper presentation formats. If you do not explicitly write out your discriminant formula before you start throwing random numbers together, the examiner has no idea what framework you're actually using. Boom, you lose the presentation mark. Warning number 2, skipping format checks before submission. This essentially means failing to check if your quadratic actually equals 0 before you identify your A, B, and C coefficients. If you pull your coefficients from a messy, unsimplified equation, your entire downstream analysis is completely corrupt. Warning number 3, answers lacking specific context. You cannot, under any circumstances, just write a final number, double underline it, and walk away. You must explicitly link your numerical finding right back to the geometric reality, stating in plain English whether it's a tangent, a chord, or no intersection. And this brings us to a brilliant point, beautifully illustrated by this quote from the examiner report: candidates consistently confuse key terminology. Always define terms before using them in extended responses. To make sure you avoid this incredibly frequent trap, I want you to memorize a very simple hack right now. We are going to use the acronym DISC, to completely lock in your comparative analysis skills. Here is how it works. D stands for discriminant. Calculate your b squared minus 4ac. I stands for indicates. Evaluate if that number is greater than, exactly equal to, or strictly less than 0. S stands for specific. Clearly state the specific number of roots, whether that's 2 distinct roots, 1 repeated root, or 0 real roots. And finally, C stands for contact. Conclude the actual geometric contact, officially labeling it as a chord, a tangent, or no intersection. If you force yourself to run this DISC protocol at the very end of every single intersection question, I guarantee you will consistently secure those contextual terminology marks. It's foolproof. We are entering Section 4, the final success blueprint. Mission complete. When you finally combine precise academic definitions, rigorous procedural execution, and crystal clear causal relationships, you are demonstrating the ultimate top-tier cross-topic integration that Cambridge rewards. Take a look at this blueprint matrix on your screen. This table flawlessly aligns Cambridge's actual cognitive assessment objectives directly with our tangent chord procedural steps. Let's break it down. Domain 1 is knowledge. This is your chance to demonstrate precise definitions. You show the examiner you know exactly what a tangent is geometrically, and you know the exact formula for the discriminant algebraically. Domain 2 is application. This is all about execution and notation. This is your raw ability to flawlessly substitute that linear equation into the circles equation, expand all the algebra without a single sign error, set the whole thing to 0, and correctly extract A, B, and C. Domain 3 is analysis. This is your comparative evaluation. This is the big finale, where you compare your calculated discriminant directly to 0, evaluate the real meaning of that specific comparison, and then draw a fully justified geometric conclusion. If your working out on the exam paper hits all 3 of these domains clearly and visibly, the examiner literally has no choice but to award you full marks. You leave them no other option. Let's lock in our absolute core rules before we wrap up. Rule 1, command word decoding. You must always know exactly what the question is asking you to prove before your pen even touches the paper. Rule 2, framework application. Religiously use the Peel method and our new DISC protocol to structure your mathematical argument logically. Rule 3, time management matrix. Do not spend 10 precious minutes staring blankly at a messy quadratic. If you followed the steps and it's just not simplifying cleanly, go back and check your initial substitution. That's almost always where the error is. Now listen, students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. I want to leave you with this final provocative thought today. If a Cambridge principal examiner picked up your very latest past paper right now, today, would they see a clear, logical, perfectly structured flight path of analytical process? Or would they see a complete crash site of unstructured, chaotic data? The difference between those two outcomes is entirely in your control from this moment forward. It all comes down to applying the exact procedural framework we've broken down in this explainer today. You need to take true ownership of your method marks. Be incredibly structured, be mathematically precise, and communicate your math so clearly that a middle schooler could follow your logic. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams, your Cambridge success starts here.